Hello, today we are going to be observing the single replacement lab. This is in place of if you were absent the day of the lab. So I've got all the metal samples laid out. These would be the elemental species that are, again, not a part of a compound that you see on your sheet. So they may be listed as chemical 1 or chemical 2. You can tell what the elemental species is because it's just the name of one element. So for example, in the first combination, you've got copper 2 chloride and lead. So when we look in this first well here, this is lead. And so when you go to write your balanced equations for any of the reactions that occurred, you should make sure you indicate the state of matter. All of these elements are metals, so the state of matter as an element would be a solid. And likewise, if you observe a reaction taking place, the product, the element that gets displaced or replaced from the compound that becomes an element, that's also going to be a solid on the product side. Our other reactant is going to be an ionic compound that is in aqueous solution. So those will have AQs next to them. You can see the bottles here with their formulas on them. If you want to copy that down, make sure you get that little 2 on the other side of the zinc nitrate. So these are going to be our ionic compounds we're using, and they are all in aqueous solution. And likewise, the product ionic compound, if a reaction takes place, will also be an aqueous solution, and you have an AQ next to its formula. Okay, so let's make the combinations. So we're going to start off with this one being lead and copper 2 chloride. So I'm going to add something to the well here, and we'll let it sit, and we'll come back and observe it. The next one is iron. We actually have these staples representing the iron sample, and we'll add some copper chloride to that, and then we'll come back and look at it in a little bit. Next one is iron, going to be combined with magnesium hydroxide, so we'll do that. And again, I'll zoom in on each of these a little bit later on so we can make our observations. Some of them you'll notice immediately there is something happening, and some of them not so much, but we'll give it a minute and see what happens. Next one is magnesium and copper 2 chloride, so we'll do that one. This one over here is going to be the zinc and copper 2 chloride, so we'll do that one. Then we've got copper and magnesium hydroxide. Then we've got zinc and magnesium hydroxide. So that's in this one. So you notice some of the particles might be kind of floating to the top of the metal. That's just because of surface tension. It's not having anything to do with the reaction or no reaction. Then we've got magnesium with calcium chloride. Sorry, my camera work is jiggling around here. I'll straighten you out so you can see everything in a minute. So this one is the magnesium and calcium chloride. And then we've got the zinc nitrate is going to go in here with copper. There. And then lastly we have oh, sorry, this was the copper with zinc nitrate. That's the last one on your list. And then lastly, we've got magnesium with zinc nitrate. So we'll put that in here. So this last one is the magnesium. Obviously, you can tell the difference between copper and magnesium. They've got a different look. Copper is copper colored, and that orangey color, and magnesium is silver. Okay, so let's take a look at what we have here. So this well 1, let's record our observations. Again, I realize apparently the iPhone camera is not as good as they claim. But in this first well, so we had a silvery solid and we've got a blue solution, and the surface of the solid is getting kind of dark. So again, we expect a reaction, if there's going to be one, to take place where the two reactants are contacting. So the fact that the rest of the solution isn't doing anything, that's okay with me, but you can actually see the surface of the lead ball is turning kind of blackish. So that would indicate that something is happening there. So what you should be recording is the observation. So we went from a silvery colored ball to a black coating, and so that's a color change. So you write down silver to black coating on the lead. The next well is iron, over here, iron and copper 2 chloride. And again, notice that we know what staples look like. Iron has that silvery, there it is over here if you want to see what it looked like without the copper 2 chloride. And we're actually getting like reddish, this camera really is not that good. there's more focused. So in this well right here is the iron with the copper 2 chloride. So notice it is getting kind of caked from being a silver color to being a reddish color, which is amazing because it's reacting with copper. So that should make a lot of sense what we see. This one, I don't see any change. Again, there's a clear colorless solution, and then I still see that silver staple. Again, it's probably hard to detect on the screen, but you'll have to trust me that there does not appear to be anything happening in there. In this one, so this is the magnesium and copper 2 chloride. Notice that the solution's actually starting to turn from blue to yellow. Actually saw a couple bubbles just get released. And then the silver surface of the metal is actually getting, again, kind of that coppery color on it. This well over here is the zinc and the copper 2 chloride. So that definitely has changed from the silvery color and the bluish solution color to like a blackish color. Over here we've got the copper with magnesium hydroxide, and there is no change there. So we've got a clear colorless solution, and then we still see that copper piece hasn't changed any color. Next over here we've got the zinc with magnesium hydroxide. Again, there appears to be no change. We've just got that clear colorless solution and my silver pieces of zinc. Over here we've got magnesium and calcium chloride, and again, it's kind of hard to see definitively on the camera, but there are no bubbles, there are no color changes. I still see the magnesium is shiny as all get out, and silvery in color just like it was before we started in the clear colorless solution. So there doesn't appear to be a change in that one for the magnesium and calcium chloride. Looking at the bottom row, we've got, again, this one over here is the second to last one. So this is the magnesium with zinc nitrate. And just gonna poke around in here a little bit. Magnesium and zinc nitrate. Now it's kind of hard to see, that's why I'm kind of poking it around. But there are actually, again, if I had a better camera, you could see this, but there are actually some bubbles forming on the surface of the metal. So, the camera's not picking it up. You'll have to take my word for it. There's some bubbles forming on the surface of the metal. So we would say there's some evidence there of something happening. And then lastly, we've got the copper in zinc nitrate, and that also does not appear to be doing anything, just like the other copper that we saw before. So there are our reactions. Again, you are figuring out which metal is more reactive in each pairing. So of the lone metal versus the metal that's a part of the compound, if there was a reaction, if you did see a sign of reaction, that means that the lone element is the more reactive metal than the one already in the compound, and that's why we're seeing a reaction. If you did not observe any reaction, that means that the more reactive metal is already bonded, it's already part of the compound, and therefore nothing's going to change. And so in that case, again, if there was no reaction observed, the more reactive element is already a part of the compound, and that's the one you should circle. And again, it's the metal in the compound, not the whole compound name, because we're looking at just one species in the compound being replaced. So there you have it. You can use that to write your lab report.